number 8, which shouldn't be, but it's considered a property, that's fine. So the constant dx from A to B. Wait, we already determined it here. It's base times height. So the base is between B and A. So this will be C, B minus A. Any questions on this? And I'd like us to apply these properties. And one more that I would like to present, which we talked about it. So if the function is greater than or equal to 0 on the interval a comma b, of course the integral from a to b from f of x dx will definitely be greater than or equal to 0. So a graph, how will this look like? Okay, so this is a and b, and the function is positive. This is f of x. The function is positive, then the area will be positive. That's all it means. Okay, greater than or equal to 0. Nothing else. Okay, so I would like us to go to, let me share my screen. And let's look at 5.2 and work on some problems. So we know the midpoint rule. We know how to calculate that. We know now what the definite integral is. We know how to evaluate definite integrals. And we know the properties, the list of properties of the definite integral. So this is what we are trying to determine now, to look at. Okay. So the midpoint rule, it's the same with the leftmost point, rightmost point. So everything is the same. So we already calculated with the left and the right. We can also calculate with the midpoint. It's the same thing. And we're going to use the same steps with the calculator that I showed you. And again, thank you, Rihanna, for asking that. It was really helpful. Okay. So a problem like this you may encounter in WebAssign. So let's look at this one problem here. I don't know. Let's look at 19. So we're not asked to calculate anything. We cannot. We don't know how to calculate this. Remember, this is the limit of the Riemann sum, delta x f of x, delta x f of x, delta x f of x. But we are not capable of determining any of this except for cubic, linear, and quadratic. For something like this, we cannot. Here, it turns out that we can. But for this, and for this, we cannot. Because we don't have those identities. We only have 4 identities, 1 for linear, 1 for quadratic, 1 for cubic, and 1 for the sum of 1. So these are completely foreign to us. So here we're only asked to express the limit as a definite integral. So let me copy limit, and I'll stop sharing. N approaches infinity from the sum from I equals 1 through n, e to xi over 1 plus xi delta x, and they are giving us 0, 1. Perfect. So you will encounter something like this for sure on in WebAssign. Okay. So we'll say the area is the same. So this is the exact area. We cannot determine it, but with this procedure. So, but definitely is between 0 and 1. Delta x is just simply dx. All I have to do is identify what the function is. So this is the spot for f of x. So now let's determine delta x. We know that delta x is 1 minus 0 divided by n going to infinity. And xi will be 0 plus I delta x. We know this from last time. If you need me to explain again, I will. So xi is nothing else but I over n. That's our xi. So this is basically I over n, and this is basically I over n. So all I have to put in is just e to the x over 1 plus x. So calculating this gives us, if we manage to determine this definite integral, that will give us the exact area that we would have been we would determine with the limit of the Riemann sum, the sum of these. There exists a way, and I want to show it to you. There is no secret. However, in this class, you have to show all steps. Yes, you can check. There is no secret. I'll show you. So with the graphing calculator, we have a way of determining. Go to math and probably scroll up if I remember correctly. Yes, right here, number 9. Okay, so the integral has 0. We're not asked to do this, but I'm showing you for any definite integral, you can determine the definite integral, not the indefinite. We haven't talked about it yet. Okay, so this is e to the x, so this is a ratio. So I have e to the x right here, and the power is x, and I divide, don't forget parentheses please, in the denominator, 1 plus x, close. When I hit enter, the calculator should give us the exact area under the given function e to the x over 1 plus x between 0 and 1. If you try, I've never tried it, but I'll try it with you. If you try to put in, for example, should give us a big error. Let's say between -1 and 10 from the function 1 over x, it should scream at me, lady, wake up. Let's see what happens. It doesn't do anything. Aha, it took a long time to think. Why is that the case? Why there is an error? And it did scream at me eventually. Why do you think? It's okay if you're wrong. Anyone?
Because you're outside the interval.
Because the function is not continuous on the interval -1, 10. Fundamental theorem of calculus is not applicable. The function is undefined at 0, and 0 is in the interval between -1 and 10. Is that okay? Okay, back. Any questions? Okay.
There was a question on chat.
Yes.
Not a different way to enter this on the TI-83.
I don't think that TI-83 has this feature. I'm not sure.
Okay.
I think what I have here is 84. Don't I have? Yeah, it's 84. I don't think that TI-83 has it. It's not useful for you. It will be useful in Calc 2 because you still have to show every step of the way. You can check, but just putting a number that the calculator gives will not be useful in this class. Okay, perfect. Let's go back. Okay. These we already know how to calculate because we are way advanced about using the fundamental theorem of calculus. What I would like to look at is, yes, we can determine if you'd like. So for example, let's say for this graph, 35, the graph of f is shown. Evaluate each integral by interpreting it in terms of areas. So choose any of these for this graph. Okay, I'm going to choose the integral from 3 to 7. So 3 is here, 7 is here. So here I have to determine this area of this triangle, base times height divided by 2. And 7, I have base times height divided by 2. But because this is positive and this is negative, I'm going to write it. You will encounter problems like this in web assign. So the integral from 3 to 7 from f of x dx, I'm going to stop sharing in a second. So we have base, which is 2, times height, which is 3, divided by 2, but minus base times height, 3 times 2, divided by 2. So the area, because this piece is positive and identical with this piece, which is negative, the answer for this case is 0. Where is my share button? Okay, so we had 2 times 3 over 2. That was the area of the triangle, minus the area of the other triangle. But the reason I have to put minus is because it's under the x-axis. So that's why this area is 0. Okay. I'd like us to practice a little bit of... So again, evaluate the integral by interpreting in terms of areas. Yes, we can graph and look at those, or just use the fundamental theorem of calculus whenever we can. We are not equipped with a lot of techniques of integration yet. There are many techniques of integration we teach in calculus 2. And in this class, we only have simple integration and substitution. These are the only two. So in this class, in chapter 5, we're going to look at simple integration and the substitution rule. Nothing else. All the other techniques of integration by parts, partial fraction decomposition, and trig substitutions, etc., they're all in chapter 6 in Calc 2. Okay. And okay, so here's an example. Yes, I would like to look at something with a piecewise defined function. So let me make up an example. Let's suppose I have a piecewise defined function that is x squared minus 3 for x between 0 and 5. And let's say e to the x plus cosine x for x greater than 5. And I'm asked to find the integral from 4 to 6 from f of x dx. This is one of the properties we just looked at. So obviously I have to break it at exactly at 5. So I have two integrals, from 4 to 5 and from 5 to 6. The integral from 4 to 5 will be from x squared minus 3 dx. And the integral from 5 to 6 will be from e to the x plus cosine x dx. And let's continue. Let's finish up and determine this area. So the antiderivative of x squared. Can anyone give us the antiderivative of x squared? Anyone?
X to the third over 3.
Of course. And minus 3x, evaluated from 4 to 5. Excellent. So can anyone give us the antiderivative of this? That will be evaluated from 5 to 6. So what do we get?
Is that,
Yes?
I'm trying to read your writing. Is that e to the x plus cosine?
Yes, it is.
So antiderivative is going to be e to the x plus sine x.
Excellent. That's it. That's all I needed. So now, in order to finish up, I have to plug in 5, 125 over 3 minus 15, minus, careful when I plug in 4, which is 64 over 3, but plus 12. If you're uncomfortable with this, put parentheses and then distribute at the end, right? Because when I plug in 4, I have to subtract. When I plug in 4, I already have a negative 12 with a minus in front will be positive 12. Now I plug in 6, e to the 6th plus sine 6, which means 6 radians, of course, minus when I plug in 5, and minus when I plug in 5. And I will say etc. here. So whenever we have a function given in the form of a piecewise defined, or a function that is a piecewise defined function, this is the procedure we use. That's one property that we looked at today. And I want to look at other properties. Here they are. Okay. And after this, we can move on. Okay. So I'll choose, let's say, 67. Unless you have something else in mind, I'm fine with whatever you choose. I'm on page 6. If you don't say anything, I'm looking at 67. So 2 less than or equal to the integral from -1 to 1, the square root of 1 plus x squared, of course dx, less than or equal to 2, the square root of 2. So please remember, I have to say that all the time. With the limit, when we determine the limit operator disappears only at the very last step. If you write the integral without dx, that is incorrect. So please make sure you always write the integral with dx. If the variable is t, then you write dt. If the variable is y, then you write dy. Don't forget dy, please. Okay, we do not have a technique at this point to determine this, and they're not asking us to determine and show that is a number between these two. No, no, no. They're asking us to use the properties of the definite integral. Properties of definite integral. This is what they're asking us to use and show that this is the case. Well, we have a property like this. If you remember, we had that property, m less than or equal to f of x, less than or equal to m, and then we integrate. Of course, dx, don't forget dx. And of course, from a to b. Okay, so this is what we are looking at. This is the property that needs to be applied here. But the question is, where do I start? And my starting point has to be here. That's my starting point. What does that mean? It means that x is between -1 and 1. That's my starting point. I don't care what the function looks like. Whatever it is, I'll get there. But my starting point is, this tells me that x is a number between -1 and 1. So these are the a and b. Okay. Now I'm looking. And I see piece by piece. I'm working on x squared. So keep in mind that if x is a number between -1 and 1, what can you tell me about x squared? And no, I'm not squaring something like this. You cannot square. I'm not saying you said anything. I'm just making sure that you understand. I'm not squaring an inequality. No. Not like this one. I could, in this case. Can I square? Yeah, of course. Like this, I can. But not when values are positive and negative. I cannot do that. So if a number is between -1 and 1, how will x squared look like? What will be the values of x squared if x is between -1 and 1? They will be between They will be between what and what?